Hello. Yeah. Hello, everyone. Let us start the class. So, where did we stop in the last class while we were in offline class? Can anyone say me? Can anyone say me? Where did we stop in the last class while we were in offline? Okay, the standard loadings. So, did we discuss this one? Uh, Impact factor. Did you discuss impact factor? Someone please unmute yourself and speak it. Okay. Okay. Fine. Thank you. So now, I guess you can see my screen. So, first of all, let us start with reinforced concrete slab bridge decks. Right? So, these are often referred to as culverts, which are used for small spans. So, what will you people do? Can you just can you just what will you do? Can you just will you just write it down like it is done in the class, or will you just look from it? What to do? Tell me. Someone unmute yourself and speak up. But you'll have to do the numericals like we do in copy. Fine, then only it will practice. Can anyone respond?
Hello.
Yeah, say. Hello, can anyone respond to it? Or all are sleeping? So, in case of reinforced concrete T-beam slabs, can you hear me now? Hello, can you hear me now? Can you all hear me now? Yes, okay, fine, fine. For slabs, the diameter and okay. So, as per Indian Road Congress, the following guidelines of control of cracking in concrete to satisfy the serviceability liquid. Okay. Now, for slabs, the diameter and spacing of reinforcing bar shall not exceed 25 mm and 150 mm respectively. So these are the certain criteria that are required to be followed. Okay. Now look, first of all, as per Indian Standard Condition (IRC), Indian Road Congress 21 2000, this is a code. So this prescribes the following guide for control of cracking in concrete to satisfy the serviceability requirements under limit state. Now for slabs, the diameter and spacing of reinforcement bar shall not exceed 25 mm and 150 mm respectively. So these are certain criteria that are required to be followed for bridge design. Now for beams, including top and bottom flanges in rectangular voided slab, the box beams, and for solid slabs, in solid slab balanced cantilever bridges, the diameter and spacing of reinforcing bar shall not exceed 32 mm and 150 mm respectively. For columns, the diameter and spacing of reinforcing bar shall not exceed 32 mm and 300 mm respectively. Okay. Now, in special cases where the stipulated detailing criteria is not satisfied, the design has to be checked for crack width limitations as specified in Appendix 1 of IRC 21 2000. Fine. Now look, here are certain properties and basic permissible stress in concrete. Fine. So properties and basic permissible stress in concrete. Number one is what? Modulus of elasticity. Number two, permissible direct compressive stress. Number three, permissible flexural compressive stress. Now, these are the certain values, okay, for different grades of conflict. So now these are the permissible stress in steel reinforcement. Okay, for different bar grades, the different permissible stresses are as follows. Hmm. Now the basic permissible tensile stress in plain cement concrete elements are limited to the values as specified in table 3.3. Now look, if you see this table 3.3 and 3.2, so here these are the permissible stress in steel reinforcement and permissible stress in plain concrete. Right? Now these are the permissible tensile stress. Okay. So here are the basic permissible stresses values. Okay. So this is the different concrete grades and these are the stresses. Fine. So these are the stresses and different concrete grades. Now these basic permissible stresses in plain concrete elements are limited to the values specified in table 3.3. Okay. Now here are the basic permissible tensile stresses in plain concrete elements. And these are limited to certain values that are specified in this table. Right. So now the detailing of reinforcement in small structural components of the bridge deck should conform to the following over requirements to ensure service and durability. So in order to ensure service and durability, what we'll have to do is, you know, the detailing of reinforcement. Huh? These are the following criteria that are to be followed. If you see the slide, so the minimum clear cover for any reinforcement bar closest to the concrete surface shall be 40 mm. Okay? Now, under severe exposure conditions, the minimum clear cover shall be increased to 50 mm. Okay? In case of foundations, in case of foundations, The following data, the minimum clear cover of any reinforcement bar closest to the concrete surface shall be 40 mm. Now, under severe exposure conditions, the minimum clear cover shall be increased to 50 mm. Now, do you know the clear cover? Any idea? Can anyone tell me what is clear cover? Yeah, someone unmute yourself and tell me what is clear cover. So, if you're not active in the class, then I'll just pinpoint your name. If you don't respond from next class onwards, I'll mark all of you absent. And people cannot join so late. Okay, there are certain people who are waiting in the lobby. This is not the way. Whenever is your wish, you will join. Today I am allowing next class just after start of 10 minutes of the class. No one will be allowed to enter. Tell me, what do you mean by clear cover? Tell me what do you mean by clear cover?
The clear cover is the distance between the
Hmm.
concrete
Hmm.
reinforcement.
So why
Distance
do you
between
use it, Michael?
so to protect the steel corrosion,
Hmm.
so to some distance between steel and to increase the
Good.
bond between.
Okay. Okay. Very good. You just tell all your friends, huh? After 10 minutes of start of the class, many people are asking me to asking me so that they can enter the class. So after 10 minutes, it will not be possible. Okay, from next time onwards. Today I am allowing all of them. Okay, so in case of foundations, the minimum clear cover shall be what? 75 mm. Now for factory made precast concrete elements with higher level of quality assurance, the cover is reduced by 5 mm. Now, look, precast means what? Precast means certain elements that are actually
So what
cast.
about 25 mm rod?
Haha,
What about 25 mm rod, sir? Clear
20,
cover.
25 mm, कौन सा?
25
Not
mm rod
25 mm
इसको clear cover कितना होना चाहिए सर?
clear cover. So this will be as per this thing only.
हाँ सर.
Okay. Okay. So these are actually
Okay sir.
specified
ठीक है सर.
as per IRC 21 2000. You can download this. You will get a PDF of this. Okay.
Okay
Now the
sir.
diameter and
Okay
spacing
sir.
of
Thank you.
bar should conform to the following specifications. The maximum diameter of reinforcing bar is limited to 40 mm. So maximum diameter of RCC bar is limited to 40 mm. Okay. Now the diameter of any what do you call it? A reinforcing bar including reverse tires, helicals, etc. Stirrups and all secondary reinforcements shall not be less than 8 mm. The diameter of longitudinal reinforcements in a column should not be less than 12 mm. So these are the certain specifications. The diameter for reinforcement in slabs is restricted to 1/10 of the depth of the slab, and the diameter of shear reinforcement in the webs of beams, including pranked bars, should be limited to 1/8 of the thickness of the web. The horizontal spacing between two parallel reinforcing bars should satisfy one of the following requirements. The horizontal spacing between two parallel reinforcing bars should specify one of the following requirements. Please mute yourself. Well, these are the certain criteria that are required to be followed. Okay, so these are certain criteria. Fine. So these are related to diameter, then horizontal spacing, the vertical distance between two horizontal main reinforcing bars. Okay, if you want, you can take a screenshot of this if you don't write. And if you're writing, just write it down. It's up to you. Tell me when it is done. Okay, is it done? Taking a screenshot of this. So these are certain criteria. You can take. Okay. Now design. Is it over? Is it over? Okay, done. Fine, fine. Okay, good. Now look, if you see this, there are certain criteria. First of all, if you can see the diameter of reinforcement bar, then diameter of longitudinal reinforcements, diameters of reinforcement slabs, horizontal spacing between two parallel bars. Why all of your friends are joining so late? Then the horizontal spacing between two parallel reinforcements. So these are the certain criteria. Okay. Now, if you go down, so here is the most important thing. Now, look, design coefficients for flexural members. Now, based on the permissible stresses compiled in table 3.1. You see table 3.1 here. Okay, you just take a screenshot of this table, this one. Tell me when it is done. Take a screenshot of this table 3.1. Screen is not visible. Is it not visible screen? The students?
Visible, sir.
Then take a screenshot now. Take a screenshot of this. My voice is not clear. Is my voice not clear?
Not clear, sir.
Voice is not clear.
Clear, sir.
Okay, voice is cracking. Some people
Clear
said.
हो
Clear,
गया सर.
sir.
Clear.
क्लियर है ना?
हाँ अभी
अभी
तो
क्लियर है
ठीक
कि
है.
नहीं?
पहले थोड़ा क्रैकिंग. हाँ क्लियर हो
क्रैकिंग हो
गया
रहा
सर.
है? हाँ, नेटवर्क का इशू होगा शायद.
नहीं हो रहा.
अभी ठीक है? Okay.
ठीक है
So
सर.
take a screenshot of this table 3.1. Maybe network issues. Yeah. Take a screenshot of this table 3.1. I think so. It is done. Okay. Screenshot लेना. And then take these two tables also, screenshot. This table 3.2 and 3.3. Tell me when you are done taking screenshots.
Done, sir.
Done? Okay, fine. Just share it with your classmates. Now, if you can see, look, in table 3.1, so here is the design coefficients, right? So in design coefficients, what is basically the thing is, these are used for computation of effective depth, that is D. Okay. Now, this in table 3.1, if you can see the properties and basic permissible stresses in concrete. Now, these are the basic permissible stresses in concrete, okay, for different grades of concrete. Fine. Now, if you can see the design coefficients can be used for computing of effective depth D for slab or beam on an area of reinforcement AST in the tension zone along with the neutral axis depth M and lever arm factor J and the moment factor Q. Okay. Now, if you have to find out N, first of all, what is N? So, if you can see, this is the neutral axis depth. Do you know what is the what is neutral axis? Do you know what is the neutral axis? Okay. So, Michael, please tell me if you know. Just try to explain.
Neutral axis is the
Hmm.
point which differentiate the compression zone
Hmm.
from zone. It's neutral axis.
So, the in neutral axis, what happens? Suppose this is the beam, right? Now, neutral axis is an imaginary axis. Okay. So, neutral axis is an imaginary axis in a beam. Now, if you see, can you, hello, can anyone tell me what is in bottom and what is in top? Like which one is tension and which one is compression? Can anyone tell me which one is tension, which one is compression?
Top tension, bottom compression.
Hmm, is it? Anyone else?
Yes,
Anyone? Hello? Anyone else?
Bottom tension. So
Hmm? Look, remember always in a beam, the bottom is always what? Tension. And upper is always what? Compression. I have to teach you now sticks. Yeah, good. Someone give the answer in the chat box also. Very good. Look, this is a beam. So here it is bending like this now. If load comes, so here it is C for compression, and here it is T. Okay. Now, if you see, we always put reinforcement in the tension side. You all know from DOS. Now, if you see, hmm, this is the compression part, right? This is the tension part. Now, in this part, when you combine all these two, okay. So now, if the stresses are zero, as said, so it is an imaginary axis where all the stresses are what? Zero. So this is called neutral axis. And neutral axis n. N A. Neutral axis depth can be found out by this formula. Now this N is what? Neutral axis depth. Now sigma ST and sigma CB. Okay. So now sigma ST and sigma CB. Sigma ST and sigma CB. How will you find out? Can anyone tell me? Sigma ST and sigma CB. Can you find out? Look, we'll go to the next table. So this is a very important table. No, no, not the code. Okay. I thought that you guys have bought the book. So this is a very important table. So this table, look, this table will give you all the values. Okay, Q, N, and J. So these are the formulas. Now sigma ST, sigma CB, if you can find out, you will be able to find out for N, J, and Q. Now look, just take a screenshot of this. Then I'm telling you something. Have you taken a screenshot of this? This is very important. Have you taken a screenshot of this? Okay. What about others? Did you guys take a screenshot of this? Fine, fine. So, okay. Uh, you just have to remember certain important values. Like for M, this one, you have to remember basically these values. I'm giving you an important. These are means these values are generally asked. Okay, it's not possible for you to remember all the values, right? You just remember M15, 20, 25, and 30. M15 will also, there are very less chances, but M20, 25, and M30. Just remember these three values. Okay, is it okay for everyone? Is it okay for everyone? Okay, so students, from next class onwards, what you people will do is, will just bring your class copies along with you. Okay, we'll switch on your speakers or whatever it be. Then we'll have to like do some numericals also, na? So then only it will be possible for us to do numericals in online mode. So take out your copies and all from next class onwards. Okay. So
अब पहले के जैसा पोर्टल में भी